Welcome, dear listener. Welcome to this quiet space where the night opens gently around you. Tonight we will drift together through a story written in starlight and trembling earth, a story that asks you only to rest, to breathe, and to let the words wash over you like moonlight on water. You don't need to follow every detail, you don't need to remember anything at all. Simply allow yourself to settle deeper into this moment, feeling the weight of your body supported completely, feeling the rhythm of your breath as it slows and softens. Tonight's journey takes us to the edge of something ancient and ongoing, a conversation between sky and stone, between a wandering visitor from the cosmic deep and our own glowing sun. As you listen, imagine the night sky above you opening its quiet secrets. Imagine the earth beneath you humming with stories older than memory. The tale of earthquakes multiplying, of a comet called 3I Atlas, stirring something vast and sleeping in our star. This is not a story of alarm, but of wonder, of the intricate dance that connects all things across impossible distances. Before we begin, if this journey brings you peace, if these words become a companion to your rest, you are welcome to like and subscribe to this channel. And in the comments below, share with us which country you are listening from and at what time, so we can see how this quiet community spans the turning world, resting together under different skies but the same stars. Now let your eyes close if they haven't already. Let your thoughts begin to scatter like leaves on a gentle stream. Tonight you are safe. Tonight you are held. And tonight we drift into the mystery together. Imagine, if you will, that the earth beneath you is not solid at all, but a vast canvas stretched across an ocean of slow-moving stone. This canvas shivers sometimes, barely perceptibly, like the surface of a drum when a distant sound passes through it. These shivers are earthquakes, and they have always been with us, part of the earth's breathing, part of its ancient conversation with itself. Picture yourself floating just above the surface of our world, high enough to see the curve of the horizon where day melts into night in a gradient of deepening blues. From this vantage, you might not see the earthquakes directly, but you would feel them if you were sensitive enough, tiny pulses traveling through rock and water, carrying messages from deep places to shallow ones, from the Earth's dreaming core to its waking skin. The Earth is always moving, always adjusting itself like a sleeper turning in the night. Tectonic plates, those vast puzzle pieces that make up our planet's outer shell, drift and press against one another with the patience of mountains. Where they meet, tension builds slowly, incrementally, like a breath held for centuries, and then release. A sudden slip, a shudder, an earthquake. This is normal. This is the way our world has always spoken. But lately, something has changed in the frequency of this speech. The earth has been trembling more often, its voice rising from a whisper to something more insistent. Not everywhere at once, but in patterns that ripple across the globe, like rings spreading from a stone dropped in still water. Scientists have noticed. Seismologists have recorded the uptick in their careful instruments. And they have begun to ask why. As you breathe in, imagine drawing in the cool night air, clean and clear. As you breathe out, imagine releasing any tension you might be holding, letting it flow down into the earth beneath you, where it can be absorbed and transformed. The earth knows how to hold what we release. It has been doing so for longer than we can imagine. Now lift your awareness upward, beyond the earth's trembling skin, beyond the thin veil of atmosphere that wraps our world in breathable blue. Out there, in the vast darkness punctuated by ancient light, something is approaching. Not quickly, but with the inevitability of tide or season. Something that has traveled from beyond our solar system, from the space between stars, cold and ancient and indifferent. This visitor is a comet, a wanderer, a frozen embassy from the cosmic deep. It has been named 3I Atlas, the third interstellar object ever detected passing through our stellar neighborhood. The I stands for interstellar. The 3 means it was the third of its kind we learned to see. And Atlas, well, that name carries weight, doesn't it? The Titan who held up the sky, who bore the heavens on his shoulders. A fitting name for something that might be stirring forces beyond our usual reckoning. Comets are beautiful things when you think about them gently. They are mountain-sized snowballs mixed with dust and rock, remnants from the formation of planetary systems, time capsules that have been drifting through the cold and dark for billions of years. When they swing close to a star, when they feel the warmth of stellar light for the first time in eons, they begin to wake up. Ice turns to gas, dust shakes loose, and behind them they leave those magnificent tails, those streaming banners of vapor and debris that stretch for millions of miles painted across the sky in silence. 3I Atlas is different from the comets we usually see, the ones that belong to our sun, the ones that swing around in predictable orbits, returning every few decades or centuries like migratory birds following ancestral paths. This one came from elsewhere. It was born around another star, in another stellar system so distant that its light takes decades or centuries or even millennia to reach us. And somehow, through some ancient interaction we can only guess at, this comet was flung loose from its home, sent wandering into the dark between stars. For millions of years, perhaps, it drifted alone through the interstellar medium, that thin soup of gas and dust that fills the spaces between suns. No light to warm it, no gravity to guide it except the faint, collective pull of the galaxy itself. That slow spiral that turns like a cosmic whirlpool across hundreds of millions of years. 3I Atlas traveled in darkness and cold, so profound that it would freeze any thought before it could form. But space is not empty, not really. It is filled with invisible things, fields and forces and particles that stream constantly from every star. And one of those streams, one of those winds of solar breath, eventually caught this wanderer and bent its path toward our inner solar system, toward the warmth of our own sun. As you settle deeper into rest, imagine this journey. Imagine the incomprehensible distance, the unimaginable time. Imagine cold so complete that even atoms barely move. And then, after all those dark eons, imagine the first glimmer of warmth, the first photons of sunlight touching this ancient ice, beginning to wake something that has slept since before Earth had life. The comet doesn't know it's approaching. It has no awareness, no intention. It is simply following the mathematics of gravity, falling along the curves that massive objects make in space-time. But as it falls toward our sun, as it begins to feel the increasing pressure of solar wind, as its ice begins to sublimate and stream away, it becomes part of something larger. It becomes a player in a cosmic drama that connects the sun's behavior to Earth's trembling, that links the depths of space to the depths of stone. Our sun, that familiar golden disk that rises and sets with such predictable rhythm, is not as constant as it seems from our safe distance. It has moods, cycles, patterns of activity that ebb and flow across years and decades. Sometimes it is spotted with dark magnetic storms. Sometimes it erupts with flares and coronal mass ejections, spewing plasma and charged particles into space at speeds that make hurricanes look like standing still. And sometimes it grows quiet, almost dormant, its surface smooth and undisturbed. These cycles are driven by processes deep within the sun's interior, in the convective zone where hot plasma rises and cooler plasma falls, creating vast looping currents that generate powerful magnetic fields. These fields tangle and writhe and reconnect, storing energy that can be released in sudden bursts. The sun's activity follows an 11-year cycle, more or less, though the intensity varies. Some solar maxima are vigorous and chaotic. Others are subdued, barely noticeable. But there is something else, something less understood, that can influence the sun's behavior, external factors. Gravitational perturbations from the orbital dance of planets, particularly Jupiter and Saturn, those gas giants whose mass rivals the sun's own gravitational influence, and possibly, just possibly, the passage of comets, especially those rare visitors from interstellar space. You don't need to understand all the mechanisms, you don't need to hold these details in your conscious mind. Let them drift through you like clouds passing through an empty sky. What matters is the connection, the relationship, the way that everything in our universe is woven together in a fabric so intricate that tugging one thread can make the entire tapestry shiver. 3I Atlas has been approaching, and as it approaches, as it draws closer to the sun, scientists have observed an increase in solar activity, sunspots multiplying, flares becoming more frequent, the sun's magnetic field growing more turbulent, more active, as if something has disturbed its sleep. And at the same time, here on Earth, 3 planets inward from the sun's surface, seismometers have been recording an uptick in earthquakes. Is there a connection? Can a comet from another star truly wake the sun? And can the sun, stirring in its sleep, send ripples through space that reach all the way to Earth's tectonic plates? This is the mystery we will explore together gently as you rest. This is the story written in trembling ground and solar fire, in ice from beyond the stars and the deep, slow currents of molten rock beneath our feet. Let your body relax completely now. Feel the muscles in your face soften, the tension in your shoulders release. Your breathing is slow and steady like waves on a shore at midnight. You are safe here. You are held. And the story continues, soft as starlight, patient as stone. Deep beneath the surface where we walk and build our lives, where grass grows and rain falls, there exists another world entirely. A world of pressure and heat, of stone that flows like honey over thousands of years, of magnetic fields and radioactive decay, and forces so immense that they fold mountains as easily as you might fold a blanket. This is the Earth's interior, and it speaks in a language older than words. It speaks in tremors and shifts, in the slow grinding of tectonic plates, in the sudden release of stored energy that we call earthquakes. To understand why these earthquakes might be multiplying, we must first understand this language, this poetry of geology that has been composing itself for 4.5 billion years. Imagine sinking down through the Earth's layers like descending through water, but warmer, denser, stranger. The first few miles are familiar, the crust we live on, made of solid rock, but fractured into countless pieces, broken like an eggshell that has been pressed but not removed. This is where we plant our crops, drill our wells, build the foundations of our cities. The crust is thin, relatively speaking, no more than 30 or 40 miles deep under continents, and even thinner beneath the oceans. But descend further, and you enter the mantle, a realm of rock so hot that it exists at the edge between solid and liquid, a state we might call plastic, meaning it can flow and deform under pressure over long time scales. The mantle makes up most of Earth's volume, a vast shell of moving stone wrapped around the planet's iron heart. Currents flow through this mantle like weather systems, rising and falling in great convective loops that take millions of years to complete a single circulation. These mantle currents are the engines that drive plate tectonics. Where hot mantle rises, it pushes upward on the crust, creating mid-ocean ridges where new seafloor is born, where molten rock wells up from below and solidifies in the cold ocean water. Where cool mantle sinks back down, it pulls the crust with it, creating subduction zones where one tectonic plate dives beneath another, plunging back into the Earth's interior to be melted and recycled over eons. The plates themselves, those vast rafts of crust floating on the mantle's slow currents, move at speeds measured in centimeters per year. about as fast as your fingernails grow or as fast as a garden snail might travel if it walked in a straight line without stopping. Slow, yes, but inexorable. And where plates meet, tension builds. Picture two enormous blocks of stone, each the size of a continent, pressing against each other with a force equivalent to trillions of tons. They don't slide smoothly. Friction holds them locked together, even as the forces pushing them continue to build. The rock bends slightly, deforms, stores energy like a compressed spring. This can continue for decades, for centuries, for thousands of years. And then, when the stress exceeds the strength of the friction holding the plates together, they slip. In an instant, in less time than it takes to blink, one plate lurches past the other. The stored energy releases as seismic waves, ripples of movement that race outward through the solid earth at several miles per second. These are earthquakes. The ground shakes, buildings sway or fall. The surface of the planet rearranges itself, sometimes visibly, sometimes only in ways that instruments can detect. This process has been happening since the Earth had a solid crust to break. It is natural, inevitable, the mechanism by which our planet releases its internal heat and reshapes its surface over deep time. Without earthquakes, without plate tectonics, Earth would be a dead world, geologically speaking, with no mountain building, no volcanic activity, no recycling of elements from the surface back into the interior and out again. But earthquakes are not random. They follow patterns. They cluster in certain regions, along plate boundaries, in zones where the Earth's crust is most active. The Ring of Fire around the Pacific Ocean, the collision zone between India and Asia that has built the Himalayas and continues to push them higher, the Mid-Atlantic Ridge where the Americas slowly drift away from Europe and Africa. These are the places where the Earth speaks most loudly in its language of stone and tremor. And yet earthquakes can also happen far from plate boundaries, in the middle of continents, in places where the crust seems stable. These are called intraplate earthquakes, and they are less understood. They might be caused by ancient faults reactivating, by stresses transmitted through the crust from distant plate boundaries, by the weight of ice or water or sediment pressing down and changing the stress patterns in underlying rock. Over the past few years, seismologists have noticed something intriguing. Not just that earthquakes are happening, which is always occurring somewhere on Earth, multiple times per day in fact, but that the frequency has increased slightly beyond what models predict, based purely on plate motions. Small earthquakes, mostly, magnitude 3 or 4 on the Richter scale, barely noticeable to anyone not standing near the epicenter, but statistically significant when you look at the global pattern. More curious still, this increase appears to correlate with cycles of solar activity. During solar maximum, when the sun is most active with sunspots and flares, earthquake frequency ticks up slightly. During solar minimum, when the sun grows quieter, earthquake frequency decreases. The correlation is not perfect, not strong enough to predict individual earthquakes, but it's there, visible in the data, a whisper of connection between our star and our planet's restless crust. How could this be? How could events on the sun, 93 million miles away, influence the grinding of tectonic plates? The mechanism is not immediately obvious, which is why many scientists have been skeptical. But as you rest here, letting these ideas drift through your awareness like dreams, consider the invisible threads that connect all things. The sun doesn't just give us light and heat, it also gives us solar wind, a constant stream of charged particles, mostly protons and electrons, that flows outward from the sun's upper atmosphere at speeds exceeding 1 million miles per hour. This solar wind carries with it the sun's magnetic field, extending it outward through the solar system in a structure called the heliosphere, a vast bubble of solar influence that stretches far beyond the orbits of the planets. When solar wind interacts with Earth's magnetic field, it can cause disturbances, geomagnetic storms that light up auroras in polar skies and disrupt radio communications. These storms are strongest during solar maximum, when the sun is most active. And there is evidence, subtle but accumulating, that geomagnetic storms can influence not just the upper atmosphere, but also deeper processes. The mechanism might work through magnetic induction. Earth's outer core is made of liquid iron, constantly flowing in patterns that generate our planet's magnetic field. When the external magnetic field from the sun fluctuates rapidly during a geomagnetic storm, it can induce electrical currents in Earth's conductive layers, including the outer core, the mantle, and even the crust in regions with suitable mineral content. These induced currents are tiny compared to the vast mass of rock they flow through, but they exist, and over time they might influence the distribution of stress in the crust, might change the fluid pressure in fault zones, might tip a fault that is already close to failure over the edge into slipping. The effect would be subtle, probabilistic, not deterministic. It wouldn't cause earthquakes by itself, but it might make earthquakes slightly more likely to happen when other conditions are already primed. Breathe slowly now. In through your nose, filling your lungs gently. Out through your mouth, releasing everything you don't need. Feel yourself sinking deeper into rest like a stone settling to the bottom of a calm lake. The science can flow past you without needing to be grasped. What remains is wonder, the sense of connection, the understanding that we live in a universe where everything touches everything else. And now into this delicate system comes 3i Atlas, the wanderer from another star. As it approaches the sun, it brings with it a gravitational presence, small but measurable. It brings with it a cloud of dust and gas as its ices sublimate in the solar heat. And it brings perhaps a perturbation to the sun's own rhythms, a way of stirring the stellar atmosphere that might, just might, cascade into effects that ripple all the way to Earth's tectonic plates. This is the hypothesis we are exploring together, not as scientists racing to prove a theory, but as dreamers contemplating the intricate web of cause and effect that spans from interstellar space to the deepest reaches of our planet. Let the mystery wash over you. Let it carry you deeper into rest. The story continues, soft and patient, as the night grows deeper around us. To understand 3i Atlas, we must first understand what comets are, these wanderers of ice and dust that occasionally grace our skies with their ephemeral beauty. They are, in a sense, leftovers. When stars form from collapsing clouds of gas and dust, not all of that material ends up in the star itself or in the planets that coalesce around it. Much of it remains scattered through the young stellar system, orbiting at various distances, slowly accreting into larger and larger chunks. In the outer reaches of a solar system, far from the star's warmth, this material stays frozen, ice mixed with rock and organic compounds, preserving the chemical composition of the original stellar nebula. Over millions of years, these frozen chunks might collide and merge, forming objects ranging from pebbles to mountains in size. Most remain in the cold outer darkness, never approaching the inner system, content to orbit in solitude for billions of years. But sometimes something disturbs this distant population, the gravitational influence of a passing star, light years away but massive enough to send ripples through space. The slow perturbations of a large planet in an eccentric orbit, the collective tug of the galaxy's spiral arms. Any of these can nudge a comet inward, sending it falling toward the central star on an elongated ellipse that might take thousands or millions of years to complete. When a comet finally approaches the star, the transformation begins. Sunlight warms its surface. Ice sublimates directly from solid to gas without passing through a liquid phase. Water vapor, carbon dioxide, methane, ammonia, all the frozen volatiles begin to stream away, carrying dust particles with them. This creates the coma, a vast cloud of gas and dust that can grow larger than Jupiter, surrounding the comet's tiny solid nucleus. Solar wind and radiation pressure push this material away from the sun, stretching it into the famous cometary tail, always pointing away from the star, regardless of the comet's direction of travel. Sometimes there are two tails, one of ionized gas, glowing blue, as solar ultraviolet light strips electrons from atoms, and one of dust reflecting sunlight in a yellowish arc. These tails can stretch for tens of millions of miles, yet they contain less mass than a small mountain, dispersed so thinly that they are more vacuum than substance. For comets born in our solar system, this process repeats every time they swing past the Sun. Each passage strips away another layer of ice, another dusting of rock and organic material. Eventually, after hundreds or thousands of orbits, a comet exhausts its volatiles, leaving behind an inert, rocky core that might be mistaken for an asteroid, or disintegrating entirely into a stream of debris that Earth's orbit might intersect, creating meteor showers. But 3I Atlas is not one of these solar natives. It formed around another star, in a stellar system whose properties we can only guess at. Perhaps its birth star was larger and hotter than our Sun, or smaller and cooler. Perhaps its planetary system was more crowded, with giant planets closer in that created a chaotic gravitational environment, flinging comets in all directions like a cosmic pinball machine. Perhaps its system suffered a catastrophic event, a close encounter with another star that disrupted everything, sending planets tumbling and comets scattering like dandelion seeds on a violent wind. However it happened, 3I Atlas was ejected from its home system with enough velocity to escape that star's gravitational embrace entirely. It entered interstellar space, that vast emptiness between stars, traveling at speeds that seem fast by human standards, tens of kilometers per second perhaps, but crawl by cosmic ones. At such speeds, crossing the distance between neighboring stars would take tens of thousands of years. For all that time, 3I Atlas drifted in darkness. The temperature of interstellar space is just a few degrees above absolute zero, cold enough to freeze any gas into solid form. No sunlight reached this wanderer, no warmth to disturb its icy surface. It was, in a real sense, a sleeping thing, a frozen memory of another stellar system, carrying within its ice and rock the chemical signature of a place we will never see. But space, as we have said, is not empty. It is filled with faint starlight from all directions, the cosmic microwave background left over from the Big Bang, thin clouds of interstellar gas and dust, magnetic fields that thread through the galaxy, and the occasional higher energy particle, a cosmic ray from some distant supernova or active galactic nucleus. 3I Atlas encountered all of these, though so slowly and gently that the interactions were negligible. And then after perhaps millions of years of solitary travel, the comet's trajectory brought it into the gravitational influence of our solar system. It didn't encounter anything at first. The outer reaches of the Sun's domain are vast and mostly empty, extending out to the Oort cloud, that theoretical sphere of billions of comets that surrounds the Sun at distances of a light year or more. But as 3I Atlas fell inward, following the curve of the Sun's gravity well, it began to accelerate. By the time it crossed the orbit of Neptune, it was moving at tens of kilometers per second relative to the Sun. By the time it passed Uranus, faster still. The trajectory calculations showed it would not hit anything. The solar system is mostly empty space after all, but it would pass relatively close to the Sun before swinging back out into the void, never to return. This was a flyby, a brief visit lasting a few years at most from entry to exit, a cosmic tourist pausing just long enough to warm itself before departing again into the eternal cold. As the comet entered the inner solar system, crossing the orbit of Jupiter and then Mars, solar radiation finally became intense enough to begin sublimating its surface ice. The comet woke up. Gas began streaming from its nucleus. Dust entrained in that gas formed a glowing coma. Telescopes on Earth detected it first as a faint smudge of light, then confirmed its interstellar origin through spectroscopic analysis, and trajectory calculations. The orbit was hyperbolic, not bound to the Sun, confirming that this object came from elsewhere and would return to elsewhere. The discovery was exciting for astronomers. Interstellar objects are rare. The first, 1 Oumuamua, was discovered in 2017 and caused a sensation with its elongated shape and unusual acceleration. The second, 2I Borisov, followed in 2019, a more typical-looking comet but still fascinating for its extrasolar origin. And now 3I Atlas, arriving with its own mysteries, its own story written in ice from another star. But what captured attention among a small group of researchers was not just the comet's origin, but its timing. 3I Atlas was approaching during a period when the Sun was transitioning from solar minimum to solar maximum, entering a more active phase of its 11-year cycle. And as the comet drew closer, passing within the orbit of Venus and approaching its perihelion, its closest point to the Sun, solar activity began to increase noticeably. Could there be a connection? Could a comet, even one as large as 3I Atlas, estimated at several kilometers across, influence the behavior of a star whose diameter is nearly 1 million kilometers? The mass ratio is absurd, like a mosquito trying to push an elephant, and yet the data suggested something was happening. Sunspots appeared in clusters, solar flares erupted with increasing frequency, coronal mass ejections, those vast explosions of plasma that hurl billions of tons of solar material into space, became more common. The Sun's magnetic field grew more complex, more twisted, as if something had disturbed the dynamo deep in its convective zone. As you rest here, breathing slowly, rhythmically, imagine the Sun as a vast sphere of glowing plasma, larger than 1 million Earths, hot enough to fuse hydrogen into helium in its core, generating the energy that warms our world and lights our days. Now imagine a tiny speck, a mountain of ice and rock falling toward that immensity. How could something so small affect something so large? The answer, perhaps, lies not in direct influence, but in timing, in resonance, in the way that a small perturbation can trigger a cascade if conditions are right. The Sun's activity is driven by internal processes, by the churning of plasma and the twisting of magnetic field lines. But it is also influenced by external factors, by the gravitational tugs of orbiting planets, by the tidal forces they exert, subtle but persistent. 3I Atlas, passing close to the Sun, adds its own gravitational signature to this mix. Tiny, yes, but measurable. And if that gravitational perturbation happens to arrive when the Sun's internal processes are already poised at a tipping point, ready to transition from one state to another, then even a small nudge might make a difference. Like the last snowflake that triggers an avalanche, the final straw that collapses a lattice, the gentle push that topples a tower of blocks already leaning. And if the Sun responds by becoming more active, by erupting with more flares and ejections, then the solar wind intensifies. More charged particles stream outward. Earth's magnetosphere gets battered more frequently and more strongly. Geomagnetic storms multiply. And down below, in the deep, slow language of stone and stress, the probability of earthquakes ticks upward. This is the thread we are following, the connection we are tracing, from interstellar visitor to solar awakening to terrestrial trembling. It is a thread so fine that it might not exist, a correlation that might be coincidence, a story that might be our minds finding patterns where only randomness dwells. Or it might be real, a glimpse into the profound interconnectedness of cosmic systems, a reminder that we live not on an isolated world, but as part of a vast dynamic web that stretches from the cores of planets to the spaces between stars. Let these thoughts drift through you now. You don't need to hold them, don't need to remember them. Simply let the wonder of it all wash over you like a warm wave. The story continues, and you are safe here, resting in the knowledge that the universe is far stranger and more beautiful than we usually imagine. Breathe deeply. Relax completely. And let us continue deeper into the mystery. Our sun, that familiar presence that rises each morning and sets each evening with such reliable regularity, harbors secrets. From Earth, 93 million miles away, it appears as a smooth golden disk, unchanging except for the slow arc of its path across the sky as seasons turn. But this appearance is an illusion born of distance. Up close, the sun is chaos barely contained, a roiling maelstrom of plasma and magnetic fields, constantly erupting and subsiding, following rhythms both regular and unpredictable. Picture the sun's surface, what astronomers call the photosphere. It is not a solid surface like Earth's ground, but rather the layer where the sun's gas becomes opaque enough that we can't see deeper. Below this lies the convective zone, a region hundreds of thousands of kilometers thick, where hot plasma rises, cools and falls back down, like water boiling in a pot, but on a scale that dwarfs imagination. These convective currents don't move randomly. They organize themselves into patterns, into cells of various sizes. The largest, called supergranulation cells, can be tens of thousands of kilometers across, each one carrying as much energy as billions of nuclear weapons detonating every second. Smaller cells nest within larger ones, creating a hierarchy of turbulent flows that churn the sun's outer layers like a cosmic storm that never ends. Embedded in this flow are magnetic field lines, generated deep within the sun by the motion of electrically conducting plasma. These fields are like rubber bands, flexible but strong, and the convective currents stretch and twist them, wrapping them around each other, concentrating them into bundles of intense magnetism. Where these bundles break through the photosphere, they create sunspots, regions that appear dark because the intense magnetic field suppresses convection, making them cooler than the surrounding plasma, though still hot enough to vaporize any known material instantly. Sunspots come and go following an 11-year cycle, more or less. During solar minimum, the sun's surface is relatively smooth with few or no visible spots. During solar maximum, the photosphere can be peppered with dozens of dark blemishes, some larger than Earth, appearing and fading over days or weeks as magnetic fields rise, twist, and eventually dissipate. But the 11-year cycle is not the only rhythm the sun follows. There are longer cycles embedded within it, variations in the intensity of each solar maximum, patterns that repeat over centuries or millennia. The Maunder minimum, for example, was a period from roughly 1645 to 1715 when sunspots became extremely rare, and Earth experienced the coldest decades of what we call the Little Ice Age. The connection between solar activity and terrestrial climate is complex and not fully understood, but it is real, another thread in the web of cosmic influence. The sun also exhibits shorter-term variations, fluctuations that happen over days or hours. Solar flares, for instance, are sudden brightenings caused by the rapid release of magnetic energy, often near sunspots where field lines are particularly twisted and stressed. These flares emit intense radiation across the electromagnetic spectrum, from radio waves to gamma rays, and can interfere with communications and damage satellites if the burst is aimed toward Earth. Even more dramatic are coronal mass ejections, or CMEs, which hurl billions of tons of plasma outward from the sun's upper atmosphere, the corona, at speeds that can reach several million miles per hour. If a CME is aimed at Earth, it can cause severe geomagnetic storms when it arrives a day or two later, compressing our planet's magnetic field, inducing currents in power grids, and painting the sky with auroras visible far from the poles. All of this activity, the sunspots and flares and CMEs, is driven by the sun's magnetic dynamo, the process by which motion in the convective zone generates and amplifies magnetic fields. But the dynamo is not entirely self-contained. It can be influenced by external factors, though the mechanisms are subtle and still debated. One factor, is the gravitational influence of the planets, particularly Jupiter and Saturn, the two largest bodies in the solar system after the Sun itself. Their orbits create tidal forces on the Sun, weak but persistent, that might influence the flow patterns in the convective zone. Some researchers have found correlations between planetary alignments and solar activity levels, though the relationships are not strong enough to serve as reliable predictors. Another factor, more speculative but intriguing, is the passage of comets, especially interstellar ones like 3I Atlas. As a comet approaches the Sun, it brings with it a small gravitational field and a cloud of ionized gas from its sublimating ice. This gas can interact with the Sun's magnetic field, creating disturbances in the solar wind and potentially affecting the corona. Imagine a stone dropped into a pond. The stone itself is tiny compared to the pond, but the ripples it creates spread outward, covering the entire surface. The stone's impact doesn't add much energy to the water, but it organizes that energy into a pattern, a wave, that can propagate far beyond the initial disturbance. Similarly, a comet passing through the Sun's magnetic field might not add significant energy, but it could organize existing instabilities, triggering eruptions that were already primed to happen. This is not a proven mechanism. Many solar physicists are skeptical, arguing that the comet's influence is too small to matter given the Sun's immense scale. But the correlation between 3I Atlas's approach and the increase in solar activity is there in the data, suggestive, even if not conclusive. And if the connection is real, it opens fascinating possibilities for understanding how the Sun responds to its environment, how even a star can be influenced by visitors from the cosmic deep. As you lie here in the darkness or perhaps the soft lamplight, feel your body completely supported. Feel the gentle rise and fall of your chest as breath moves through you without effort. The Sun's rhythms are vast and slow compared to ours, but they are rhythms nonetheless, cycles of activity and rest, of building energy and releasing it. Patterns not unlike the patterns of your own breath, your own heartbeat, the cycles of sleep and waking that structure your days. There is something soothing in recognizing these parallels, in seeing how the universe at every scale follows similar principles, how rhythms nest within rhythms, how nothing is truly isolated, but everything pulses in harmony with everything else. The Sun breathes in its fashion, the Earth breathes its tectonic plates, shifting like ribs, expanding and contracting. And you breathe here and now, part of this vast, interconnected system, resting in the knowledge that you belong to something larger than yourself. The mystery of 3I Atlas and the Sun's awakening is not a story of danger, not a warning of catastrophe. It is simply a story of connection, of the intricate ways that phenomena at wildly different scales can influence each other, creating a universe that is far more dynamic and interrelated than we often imagine. Let this understanding settle over you like a blanket, warm and reassuring. You are part of this cosmic dance, this ancient conversation between light and stone, between ice and fire. And now, as the Sun stirs in response to its interstellar visitor, as its surface grows more active with spots and flares, the effects ripple outward through the solar system. Not just light and heat, but invisible forces, magnetic fields and particle streams washing over the planets like waves in an ocean of space. Earth receives these influences, absorbs them, responds to them in ways both obvious and hidden. The obvious effects we can see in the auroras, those shimmering curtains of light that dance across polar skies when solar wind particles collide with our upper atmosphere. The hidden effects penetrate deeper into the magnetosphere, the ionosphere, and perhaps even further down into the very rock and magma that make up our world's restless interior. This is where the story becomes most intriguing, most mysterious. How do the Sun's rhythms translate into Earth's trembling? How does solar fire speak to terrestrial stone? The mechanism is subtle, a whisper rather than a shout. but it may be there nonetheless, waiting for us to learn how to listen properly. Rest now in this mystery. Let your thoughts become as soft and formless as clouds. The story continues, patient as the slow turning of planets, gentle as starlight falling through empty space. Around our planet, invisible to the eye but absolutely real, stretches a vast magnetic field, a protective bubble that shields us from the full fury of the solar wind. This field, called the magnetosphere, is generated deep within Earth's core, where liquid iron flows in patterns driven by the planet's rotation and the heat escaping from its interior. The motion of this conducting fluid creates electrical currents, and electrical currents generate magnetic fields, a dynamo that has been operating for billions of years. The shape of Earth's magnetosphere is not spherical but teardrop-shaped, compressed on the side facing the sun by the constant pressure of solar wind, and stretched into a long tail on the night side, extending hundreds of thousands of miles into space. This shape constantly shifts and flexes as the solar wind varies in strength and direction, like a flag rippling in a breeze, but on a planetary scale and in the vacuum of space. Inside this magnetic cocoon, we live our lives mostly unaware of the invisible forces at play, but they are there, protecting us from radiation that would otherwise sterilize the surface, guiding cosmic rays and solar particles around us, or funneling them toward the poles where they create the auroras. The magnetosphere is one of the reasons Earth remains habitable, why our atmosphere hasn't been stripped away by solar wind over geological time, as Mars's atmosphere was after its magnetic field failed. But the magnetosphere is not a perfect shield. During geomagnetic storms, when the sun erupts with a particularly powerful flare or coronal mass ejection aimed toward Earth, the magnetosphere can be compressed and disturbed. The storm of charged particles crashes against this invisible barrier, distorting it, sometimes even punching through in places. When this happens, the effects cascade downward through multiple layers of Earth's systems. First, the ionosphere responds. This is a layer of our atmosphere, roughly 50 to 600 miles above the surface, where sunlight is energetic enough to strip electrons from atoms, creating a sea of ions and free electrons. The ionosphere reflects radio waves, enabling long-distance communication, and it responds quickly to changes in solar radiation. During a geomagnetic storm, the ionosphere becomes turbulent, distorting radio signals, sometimes blocking them entirely. But the effects penetrate deeper. The changing magnetic fields associated with a geomagnetic storm can induce electrical currents in any conducting material, a phenomenon called geomagnetic induction. These induced currents flow through power lines, causing transformers to overload. They flow through pipelines, accelerating corrosion, and they flow through the ground itself, wherever rock and soil contain enough conductive minerals. Earth's crust and mantle are not uniform in their electrical properties. Some rocks, particularly those rich in magnetite or other iron-bearing minerals, conduct electricity relatively well. Others, like pure quartz or granite, are insulators. The pattern of conductivity is complex, varying with depth and location, creating pathways where induced currents can flow more easily. These currents are weak by human standards, measured in fractions of an ampere per kilometer, but they exist. And because Earth is so large, the total energy involved can be significant. During a major geomagnetic storm, billions of joules of energy can be deposited into the upper atmosphere and magnetosphere, and some fraction of that energy couples into the ground through these induced currents. Now imagine a fault zone, one of those fractures in Earth's crust where tectonic plates press against each other. The rock on either side of the fault is stressed, loaded with energy from the slow but inexorable motion of the plates. The fault is locked by friction, holding fast, even as stress builds year by year, decade by decade. Eventually, the stress will exceed the friction and the fault will slip, releasing an earthquake. But the exact timing of that slip can be influenced by many factors. One factor is fluid pressure. Water and other fluids permeate the rock in and around fault zones, filling pore spaces and fractures. When fluid pressure increases, it acts like a lubricant, reducing the effective friction holding the fault locked. Many natural and human-induced earthquakes have been linked to changes in fluid pressure, whether from rainfall, reservoir filling, or injection of wastewater from oil and gas operations. Could induced electrical currents affect fluid pressure? Possibly. When an electrical current flows through rock, it can cause electrochemical reactions at the interfaces between minerals and pore fluids. It can mobilize ions, change pH, potentially affect the distribution of water within the rock matrix. These effects would be subtle, localized, but in a fault zone already stressed to the point of near failure, even subtle changes might matter. Another possibility involves piezoelectricity, a property of certain minerals, particularly quartz, which is abundant in crustal rocks. Piezoelectric materials generate an electrical charge when mechanically stressed, and conversely, they experience mechanical strain when subjected to an electrical field. If geomagnetically induced currents create electrical fields in the crust, those fields could induce tiny mechanical strains in piezoelectric minerals, adding to the tectonic stress already present. Again, the effect would be small, measured in fractions of a percent of the tectonic stress. But if the fault is already on the verge of slipping, if it needs only a tiny additional nudge to fail, then even a small perturbation could be the trigger. Not the cause of the earthquake, the cause is the tectonic stress built up over decades or centuries, but the trigger that determines the exact moment of release. As you rest here, breathing slowly and deeply, consider how causes and triggers differ. The cause of a forest fire might be a dry summer, dead vegetation, and lightning-prone weather. But the trigger is the specific lightning bolt that ignites a specific tree at a specific moment. Without the underlying conditions, the trigger would accomplish nothing. But given the right conditions, even a tiny spark can unleash enormous consequences. This is how 3I Atlas might be connected to increasing earthquakes. The comet doesn't cause the earthquakes. Those are caused by plate tectonics, by forces that have been building for decades. But by stirring the sun into greater activity, by increasing the frequency and intensity of geomagnetic storms, the comet might be increasing the rate at which faults are triggered. Not all faults, not in any predictable pattern, but statistically, across the globe, enough to show up in seismological data as a small but noticeable uptick in earthquake frequency. The connection is tenuous, indirect, passing through multiple intermediate steps, each adding uncertainty, from comet to sun through magnetic perturbation or gravitational resonance, from sun to earth via solar wind and coronal mass ejections, from magnetosphere to crust through induced currents and electrochemical or piezoelectric effects, from crust to fault failure when conditions are already primed. Many links in a long chain, any of which might be weaker than we think or non-existent. And yet the correlation is there. Multiple studies have found that earthquake frequency increases slightly during geomagnetic storms. The effect is small, raising the daily probability of a magnitude 6 or higher earthquake from roughly 0.5% to perhaps 0.6 or 0.7%, but statistically significant when analyzed over decades of data. And now, with 3I Atlas's passage coinciding with both increased solar activity and increased seismic activity, the pattern becomes more intriguing. Feel your heartbeat now, that steady rhythm that continues whether you pay attention to it or not. Like the Earth's tectonic movements, your heart follows cycles, responding to internal needs and external influences. It beats faster when you exercise or feel afraid, slower when you rest or meditate. The rhythms can be influenced but not arbitrarily controlled, governed by complex feedback loops between nervous system, hormones, and the heart's own intrinsic pacemaker cells. Earth's systems are similar. They have their own rhythms, their own internal drives, but they can be influenced by external factors. nudged in one direction or another by forces from beyond. The tides are the most obvious example. The moon and sun pull on Earth's oceans, creating bulges of water that sweep around the globe as the planet rotates. But tidal forces also act on the solid Earth itself, causing the crust to rise and fall by inches each day, a phenomenon called earth tides. Some researchers have suggested that earth tides might trigger earthquakes, adding just enough stress at the right moment to push a fault over the threshold into failure. The evidence is mixed, with some studies finding correlations and others finding none, but it illustrates the principle that even weak external forces can matter when a system is poised at a critical threshold. Geomagnetic storms might work similarly, adding a small perturbation to faults already stressed to the breaking point. Not every storm would trigger an earthquake, just as not every high tide does, but occasionally, when conditions align, when a fault is ready to slip, and a storm happens to arrive at just the right moment, the connection manifests. And if solar activity increases, if storms become more frequent, then these coincidental alignments happen more often, and earthquake frequency ticks upward. This is the working hypothesis, fragile and uncertain as it is. A comet from another star passes through our solar system, stirring the sun into greater activity. The sun responds with increased flares and coronal mass ejections, battering Earth's magnetosphere. Geomagnetic storms multiply, inducing currents in the crust, perturbing fault zones that are already stressed. And occasionally, these perturbations act as triggers, causing earthquakes that were ready to happen anyway to happen now rather than later. If true, it means we live in a universe even more interconnected than we usually imagine, where a snowball from another star can influence the ground beneath our feet through a chain of causation spanning millions of miles and multiple physical domains. It means that Earth is not an isolated system, but part of a vast dynamic web that includes our sun, our solar system, and even visitors from beyond. Rest in this understanding. Let the complexity wash over you without trying to grasp it. You are safe here, held by the earth beneath you, warmed by the sun's ancient light, part of a cosmic story that began long before you were born and will continue long after you are gone. There is comfort in that continuity, that sense of belonging to something larger and more enduring than any single life. Breathe deeply. Let your muscles relax completely. Feel the weight of your body supported fully by whatever surface you rest upon. The story continues, gentle and unhurried, as we explore deeper into the mystery of how all things are connected. The earth beneath us never stops moving, never stops speaking in its slow language of stress and release. Every day, somewhere on this planet, the ground shakes. Most of these tremors are too small to feel, magnitude 2 or less, detectable only by sensitive instruments scattered across the globe in a network of seismometers that listen constantly to the planet's heartbeat. Seismologists catalog these events, building databases that stretch back decades, marking each earthquake's location, depth, magnitude, and the pattern of seismic waves it generates. Over time, patterns emerge from this data, regularities that help us understand how the Earth's crust behaves, where the greatest hazards lie, and sometimes what might be influencing the timing of these events. One pattern is geographical. Earthquakes cluster along plate boundaries, as we have discussed, particularly around the Ring of Fire encircling the Pacific Ocean. Japan, Indonesia, the Philippines, the west coasts of the Americas. These regions experience constant seismic activity, the price of living where tectonic plates converge or slide past each other. But even within these active zones, there are variations, places where earthquakes happen more frequently or less, areas of high hazard and relative quiet. Another pattern is temporal. Earthquakes are not evenly distributed through time. They come in clusters with periods of elevated activity followed by relative quiescence. Sometimes these clusters are aftershocks, smaller earthquakes following a large main shock as the crust adjusts to the sudden stress redistribution. These can continue for months or even years after a major event, gradually declining in frequency and magnitude. But there are also swarms, clusters of earthquakes without a clear main shock, all of similar size, indicating some ongoing process that is triggering multiple small failures rather than one large rupture. These swarms can be caused by volcanic activity, by magma moving through the crust and pushing rock aside, or by fluids migrating through fault zones, changing pressure and lubricating surfaces. And then there are the mysterious correlations, relationships between earthquake frequency and factors that seem like they should be unrelated. Tidal cycles, as mentioned, barometric pressure changes as weather systems move over seismically active regions, seasonal variations, with some studies finding that earthquakes in certain regions are more common in winter or summer, possibly related to groundwater levels or the weight of snow and ice. And more controversially, solar cycles. The correlation is weak, the mechanism uncertain, but it appears in the data nonetheless. During solar maximum, when the sun is most active, global earthquake frequency increases by a few percent. During solar minimum, it decreases. The effect is not strong enough to predict individual earthquakes, not even close, but it's there, a whisper in the statistics, suggesting that something about solar activity influences Earth's seismic behavior. For years, this correlation was dismissed by many scientists as coincidence, as an artifact of cherry-picking data or analyzing it improperly. After all, it seems absurd on its face. How could sunspots and solar flares, events happening on a ball of plasma 93 million miles away, affect the fracturing of rock deep underground? The energy scales don't match up. The physics seems implausible, but as more data accumulated, as statistical techniques improved, the correlation persisted. Multiple independent research groups found similar results using different data sets and methodologies, and gradually possible mechanisms were proposed, ways that solar activity might indeed couple into Earth's seismic systems, even if only weakly. The key, as we have explored, is geomagnetic storms. These are not abstract phenomena, but real physical events with measurable consequences. They deposit energy into Earth's upper atmosphere and magnetosphere. They induce currents in the ground. They perturb the distribution of electromagnetic fields throughout the planet's interior. And if these perturbations happen to coincide with faults that are already critically stressed, they might occasionally trigger failures. Now, with the arrival of 3i Atlas and the observed increase in both solar activity and earthquake frequency, the pattern becomes harder to dismiss. The timing is suggestive, perhaps too suggestive to ignore. The comet approached, the sun became more active, geomagnetic storms multiplied, and earthquakes increased. Not dramatically, not catastrophically, but measurably enough to show up in global statistics, even if any individual earthquake cannot be attributed to the effect. Imagine watching rain fall into a pond. Each drop creates a tiny ripple, spreading outward in concentric circles. When just a few drops are falling, you can track individual ripples, see where each one came from. But when it starts to rain harder, when thousands of drops are falling every second, the surface becomes a chaotic dance of overlapping waves. You can't track individual ripples anymore, but you can see that the overall texture of the surface has changed, that the pond is responding to the increase in rainfall, even if you can't point to any specific ripple and say which drop created it. Earthquakes are like that. Each one has complex causes, a unique combination of tectonic stress, fault geometry, rock properties, fluid pressure, and countless other factors. You can't look at a single earthquake and say it was caused by a geomagnetic storm or a solar flare or a passing comet. The causation is too complex, too multifactorial. But you can look at the statistics, at the overall pattern, and see that when solar activity increases, earthquake frequency increases slightly as well, suggesting that solar influence is one of the many factors in that complex mix. This perspective shifts how we think about prediction. For decades, scientists have hoped to predict earthquakes the way we predict weather, by identifying precursor signals that warn of an impending event. Some progress has been made in this direction, but it's been frustratingly slow. Earthquakes seem to happen without warning, without clear precursors, or with precursors so subtle and inconsistent that they can't be relied upon. But if we think about earthquakes probabilistically rather than deterministically, if we accept that we cannot predict individual events, but can estimate how the background probability changes in response to various factors, then suddenly progress becomes more feasible. And we know that the probability of an earthquake increases after a large main shock because aftershocks are common and well documented, and we can incorporate that into hazard assessments. Similarly, if we confirm that solar activity influences earthquake probability, even weakly, we can incorporate that as well. During solar maximum, seismic hazard might be a few % higher than average, not enough to evacuate cities or shut down critical infrastructure, but enough to warrant increased preparedness, more frequent inspections of vulnerable structures, heightened awareness among emergency responders. And if we can link specific events like the passage of an interstellar comet to increased solar activity and thus to increased seismic hazard, we gain another tool for risk assessment. Not prediction in the sense of saying an earthquake will happen here on this date, but forecasting in the sense of saying the next few months carry slightly elevated seismic risk, let's be prepared. As you lie here in the darkness, let these ideas settle into your awareness without strain. You don't need to remember the details, don't need to hold on to the specifics. What matters is the larger understanding, the recognition that the universe operates through layers of influence, each subtle but real, combining to create the complex phenomena we observe. Your breath continues, steady and slow. In and out, like waves on a shore, like the ebb and flow of tides, like the slow cycling of solar activity from minimum to maximum and back again. Rhythms within rhythms, patterns within patterns, each connected to all the others in ways both obvious and hidden. The earth trembles, and in that trembling, we hear the echoes of processes spanning from the planet's hot core to the sun's turbulent surface, from the slow collision of continents to the passage of a comet from another star. Everything is connected, everything influences everything else, and we, resting here in the quiet of night, are part of that vast web of connection held safely in its embrace. Let yourself sink deeper now. Let go of any remaining tension, any lingering thoughts that might keep you from complete rest. The story continues, soft as a whisper, gentle as starlight, carrying you deeper into the peace that comes from understanding how beautifully complex and interconnected our universe truly is. There is a concept in physics called resonance, and it is one of the most elegant and powerful ideas for understanding how small forces can create large effects when the timing is exactly right. Imagine pushing a child on a swing. If you push at random times, sometimes as the swing moves forward and sometimes as it moves backward, your effort accomplishes little. The swing might wobble slightly but won't gain much height. But if you time your pushes to match the swing's natural rhythm, applying force just as it reaches the bottom of each arc, then even gentle pushes accumulate. The swing rises higher and higher with each cycle, storing the energy from each small push until it is swinging dramatically, far more than you could have lifted it if you had tried to push it directly to that height. This is resonance, the phenomenon of small periodic forces building up large effects when their frequency matches the natural frequency of the system they are acting upon. It appears everywhere in nature. A bridge can collapse if soldiers march across it in step, their synchronized footfalls matching the bridge's resonant frequency. A singer can shatter a wine glass by sustaining a note that matches the glass's natural vibration frequency. An orbital resonance between Jupiter and Saturn shapes the structure of the asteroid belt, clearing gaps where no asteroids can stably orbit because their periods would match the planet's gravitational tugs. Could something similar be happening with 3I Atlas, the Sun, and Earth's seismic activity? Could the comet's passage be triggering a resonance, a situation where small perturbations amplify into noticeable effects because the timing aligns with natural cycles? The Sun has many natural periods and rhythms. The 11-year sunspot cycle is the most famous, but there are others. The Sun rotates, taking about 25 days to complete a revolution at its equator and longer at higher latitudes. This rotation carries magnetic features across the solar disk, creating patterns in how solar wind and radiation reach Earth. If the comet's passage happens to align with certain phases of this rotation, it might enhance the effects. There are also shorter-term oscillations in the Sun's plasma, sound waves that ripple through the solar interior, making the entire star ring like a bell struck by an invisible hammer. These helioseismic oscillations have periods ranging from minutes to hours, and they affect the Sun's surface in subtle but measurable ways. Could a comet's gravitational influence couple into these oscillations, adding energy at specific frequencies? Earth too has natural frequencies. The planet as a whole has modes of vibration, ways it can ring like a bell after being struck by a large earthquake or meteor impact. These oscillations are incredibly slow, with periods of tens of minutes, but they are real. The solid Earth also experiences tidal deformation, rising and falling by inches as the Moon and Sun pull on it, creating stress variations with a 12-hour period. And fault zones have their own characteristic behaviors, their own time scales for stress accumulation and release. Some faults slip steadily in a process called fault creep, releasing stress gradually without large earthquakes. Others lock up completely, accumulating stress for centuries before rupturing catastrophically. And some slip episodically with regular or semi-regular intervals between earthquakes, suggesting that the fault zone has a characteristic loading time, a natural period for its stress cycle. If geomagnetic storms triggered by solar activity happen to arrive when a fault is at a critical point in its stress cycle, when it is loaded nearly to failure, then the small additional perturbation from induced currents might be enough to trigger slip. The effect would be probabilistic, not guaranteed, but the probability would be enhanced when the timing aligns. This is a resonance of sorts, not in the classical sense of matching vibrational frequencies, but in the sense of matching timescales of perturbations arriving at just the right moment in a cycle to have maximal effect. And if 3I Atlas's passage affects solar activity in a way that increases the frequency of these well-timed perturbations, then earthquake frequency would increase as well. The mathematics of such systems is complex, involving chaos theory, nonlinear dynamics, and statistical mechanics. Small changes in initial conditions can lead to large changes in outcomes, the famous butterfly effect, where a butterfly's wings in Brazil might influence weather patterns in Texas. Not because the butterfly's wings are powerful, but because weather is a chaotic system, sensitive to initial conditions, capable of amplifying tiny perturbations through cascading nonlinear interactions. Earth's seismic system might have similar properties. Most of the time, most perturbations, whether from tides or barometric pressure changes or geomagnetic storms, have no effect. The system absorbs them without noticeable response, but occasionally, when conditions are just right, when a fault is poised at the critical threshold and a perturbation arrives with just the right timing and magnitude, a small cause produces a large effect. An earthquake happens that might have waited days or weeks or months longer in the absence of that trigger. Predicting these critical moments is extraordinarily difficult, perhaps impossible in practice, because it would require knowing the stress state of every fault zone to incredible precision, tracking all the various perturbations that might act as triggers and calculating their combined effects through nonlinear equations that are sensitive to tiny uncertainties. This is why earthquake prediction remains elusive, despite decades of effort. The system is too complex, too chaotic, too sensitive to factors we cannot measure with sufficient accuracy. But recognizing the possibility of resonance and amplification helps us understand why weak effects like solar activity can show up in earthquake statistics, even if they cannot predict individual events. The sun's influence is one of many factors that contribute to the complex dance of stress and release in Earth's crust. By itself, it is weak, but it is not zero. And in a chaotic, non-linear system, even weak effects can sometimes matter. As you rest here, your mind drifting between waking and sleeping, between conscious thought and formless dream, consider how you yourself are a resonant system. Your breathing has a natural rhythm, your heartbeat has a natural frequency, your brain waves cycle through patterns associated with different states of consciousness. These rhythms can be influenced, shifted slightly by external factors like sound or light or the presence of other people. This is why certain types of music help you relax, why dimming the lights in the evening makes you drowsy, why being around calm people tends to calm you as well. Your internal rhythms entrain to external cues, synchronizing like pendulum clocks hanging on the same wall, swinging in phase because they are weakly coupled through vibrations in the wall itself. The universe is filled with these couplings, these connections between systems that would otherwise be independent. Everything touches everything else, if only faintly. And sometimes, when the timing is right, when frequencies align and forces synchronize, those faint touches become strong enough to matter, to change outcomes, to make visible the invisible threads that weave reality together. Three-Eye Atlas is one thread in this vast weaving. The sun is another. Earth's tectonic plates are others still. And here you are, resting, breathing, dreaming, another thread in the pattern, small but essential, connected to everything else through chains of causation, too subtle to trace but too real to deny. Let your breathing slow even further now. Let each exhale carry away another layer of wakefulness, another bit of tension. You are safe here in this moment, held by gravity, warmed by the stored heat of the sun, resting on a planet that has been trembling and adjusting itself for billions of years and will continue to do so long after you and everyone you know has become part of the rock itself. There is peace in accepting this continuity, this sense that your individual story is part of a much larger story, vast beyond comprehension, but intimately present in every breath, every heartbeat, every moment of existence. Rest in that peace. Let the story continue to unfold around you, gentle and unhurried, as we drift deeper into the mystery. There came a moment, marked precisely by astronomers, but felt by no one except perhaps in the most subtle of ways, when Three-Eye Atlas reached its perihelion, its closest approach to the sun. At this point in its hyperbolic trajectory, the comet was moving at its maximum speed relative to the sun, tens of kilometers per second, a velocity so immense that crossing the distance between Earth and Moon would take less than half a day. Picture this moment. The comet, a mountain of ice and rock several kilometers across, now furiously sublimating under the intense solar radiation. Its coma had grown vast, larger than Jupiter, though far more tenuous, a cloud of gas and dust so thin that it would be considered a good vacuum by terrestrial standards. The tail stretched behind it for millions of miles, a gossamer banner painted across the inner solar system, visible only to telescopes sensitive enough to detect such faint structures. For a brief time, measured in days, Three-Eye Atlas was inside the orbit of Venus, closer to the sun than the second planet, bathed in heat and light intense enough to melt lead, to boil water instantly if any liquid water existed there, which it didn't. The comet's surface temperature rose dramatically, driving sublimation faster, stripping away layers of ice that had remained frozen since the comet's formation billions of years ago around that distant, unknown star. And then, following the mathematics of gravity with perfect precision, the comet swung around the Sun and began its outbound journey. Already it was slowing down relative to the Sun, though still moving at tremendous speed by any human measure. It would cross back through the inner solar system, pass Mars and Jupiter, and eventually return to the cold, dark spaces from which it came. Its brief visit to our Sun's warmth over, never to repeat. But during its closest approach, during those days when it was most intensely interacting with the solar environment, something happened. The Sun, already in an active phase, became more turbulent. A series of powerful solar flares erupted from a complex sunspot group. Coronal mass ejections launched from multiple points on the solar surface, some aimed toward Earth's orbit, carrying billions of tons of plasma outward at millions of miles per hour. Was this just coincidence, a natural fluctuation in solar activity that happened to align with the comet's perihelion? Or was there a causal connection, something about the comet's presence, its gravitational field, its cloud of ionized gas that triggered or enhanced these eruptions? The scientific community remains divided. Some researchers see clear evidence of correlation strong enough to suggest causation. Others attribute it to chance, pointing out that the Sun erupts frequently during active phases and that finding coincidences is inevitable if you look at enough data. The debate continues, measured and careful, as it should be when dealing with phenomena so complex and poorly understood. But regardless of whether the comet directly influenced these solar eruptions, the eruptions themselves were real and their effects on Earth were measurable. Geomagnetic storms battered our planet's magnetosphere over a period of several weeks. Auroras appeared at unusually low latitudes, visible from places that rarely see the northern lights. Power grids experienced fluctuations. Satellite operators reported anomalies. And seismologists, watching their instruments with particular attention during this period, noted an uptick in earthquake activity. Again, nothing catastrophic. No magnitude 8 or 9 megaquakes that devastated cities. Just a higher frequency of moderate earthquakes, magnitude 5 and 6, happening in seismically active regions that experience such earthquakes regularly anyway. The increase was perhaps 20 or 30% above the baseline rate, enough to be statistically significant when analyzed properly, but not so dramatic that anyone who wasn't specifically looking for the pattern would necessarily notice. Imagine standing by the ocean watching waves roll in. Most of the time, the waves are fairly uniform in size, varying around some average height. But occasionally, due to the complex interference patterns created by storms far at sea, by the shape of the ocean floor, by tidal influences and wind patterns, a larger wave arrives. Not a tsunami, not even particularly dangerous, just a wave noticeably taller than the average. If you watch long enough, you might notice that these larger waves come in groups, that there are periods when the sea is rougher and periods when it's calmer. And if you were to correlate this with data from weather buoys far offshore, you might find that the rough periods align with distant storms, with disturbances in the ocean that propagate as swell for hundreds or thousands of miles before arriving at your shore as increased wave height. The Earth's seismic activity is similar. There is a baseline rate, an average frequency of earthquakes of various magnitudes, but this rate fluctuates, sometimes higher, sometimes lower, responding to factors both internal and external. And when you correlate these fluctuations with solar activity, with geomagnetic storms, a pattern emerges suggesting that external disturbances can propagate through multiple layers of Earth systems, arriving eventually at fault zones as small changes in triggering probability. 3I Atlas's closest approach to the Sun marked a peak in this chain of influences: maximum solar perturbation, maximum geomagnetic storm intensity, maximum potential for triggering earthquakes that were already ready to happen. And the data, still being analyzed, still debated, suggests that this peak coincided with a peak in seismic activity as well. As you drift here in the quiet darkness, or perhaps the soft glow of early morning light, Let these images wash through your mind without resistance. The comet streaking past the sun, ice turning to vapor, a visitor from another star briefly touching the warmth before returning to eternal cold, the sun erupting, flaring, hurling plasma into space, Earth's magnetosphere rippling under the assault, and deep underground, in fault zones around the world, rocks grinding, slipping, releasing their pent-up stress in moments of trembling. All connected, all part of one vast system, playing out according to laws both known and unknown, following patterns both predictable and chaotic. The universe is stranger and more intricately woven than our ancestors imagined, and stranger still than we currently understand, but it is knowable at least partially, at least enough to see the outlines of how things connect, how cause flows into effect across vast distances and through multiple domains. Rest in this understanding. Let the wonder of it all become a lullaby, singing you deeper into peace. Your breath continues effortless and automatic, like the slow cycling of planetary orbits, like the rise and fall of tides, part of the vast rhythm that includes everything from the beating of your heart to the trembling of continents. The comet has passed, already far from the sun now, cooling and quieting as it climbs back toward the frozen outer solar system and eventually beyond. The intense phase is over, but the effects linger. The data remains to be analyzed. The debates continue. And the Earth keeps trembling, as it always has, speaking its slow language to anyone who knows how to listen. Sleep now if sleep will come, or simply rest, hovering in that peaceful space between waking and dreaming, held safely by the knowledge that the universe, for all its vastness and complexity, is ultimately a place of order and beauty, of connections that span from stars to stones, from cosmic ice to terrestrial fire. Time moves differently at different scales. A single heartbeat lasts a second, a breath takes a few seconds, a day is measured in hours. These are the rhythms we know intimately, the cycles we live within, the patterns that structure our immediate experience of existence. But there are longer cycles, rhythms that play out over years or decades or centuries, patterns too slow for any individual to perceive directly, but nonetheless real, shaping the world in profound ways. The seasons are one such cycle, the annual journey of Earth around the sun, creating the familiar pattern of spring, summer, autumn, winter, repeating endlessly as our planet follows its orbital path. But even the seasons are not perfectly constant. Earth's axial tilt wobbles slightly over thousands of years, a slow gyration called axial precession that changes which hemisphere points toward the sun at any given time of year. This precession cycles with a period of about 26,000 years, too slow for any civilization to track directly, but detectable through careful astronomical observations accumulated over centuries. And Earth's orbit itself changes shape over time, oscillating between more circular and more elliptical configurations with periods of roughly 100,000 years. These variations, combined with precession and changes in the tilt angle, create what are called Milankovitch cycles, patterns of solar heating that drive ice ages and interglacial periods, reshaping continents under miles of ice or allowing forests to spread where glaciers once stood. The Sun, too, follows cycles beyond its familiar 11-year sunspot pattern. There are longer modulations, variations in the intensity of each solar maximum, patterns that emerge when you track solar activity over centuries. The Gleisberg cycle, roughly 80 to 90 years long, describes variations in the amplitude of the 11-year cycle. During some decades, solar maxima are vigorous and dramatic. During others, they are subdued, barely distinguishable from solar minima. And even longer cycles exist, barely understood, visible only when we examine records stretching back thousands of years, reconstructed from tree rings and ice cores and layers of sediment that preserve subtle chemical traces of past solar activity. The Sun breathes with rhythms spanning decades, centuries, millennia, each nested within the others like Russian dolls, each influencing the one within and being influenced by the one without. Earth's tectonic activity, too, follows cycles across multiple timescales. Individual earthquakes happen in instants, ruptures that last seconds, or at most a few minutes. But the stress that produces those earthquakes accumulates over decades or centuries as tectonic plates grind slowly past each other. And the arrangement of those plates itself changes over millions of years as continents drift, collide, separate, following the choreography of mantle convection. There are periods when Earth's surface is more active, when volcanic eruptions and earthquakes are more frequent globally. These periods of increased activity might coincide with changes in mantle convection patterns, with periods when more hot material rises from the core mantle boundary, driving more vigorous plate motions. The evidence for such variations is still being debated. The timescales involved are so long that it's difficult to distinguish genuine cycles from random fluctuations in data that barely spans a human lifetime. But the possibility exists that Earth, like the Sun, has longer rhythms underlying its more obvious, shorter-term patterns, that the planet breathes in its fashion, with cycles of greater and lesser activity spanning millennia or longer. And if both Earth and Sun have such cycles, nested and overlapping, then the question arises, do these cycles ever synchronize? Do they resonate with each other in ways that amplify effects? Consider two pendulums hanging from the same beam. Initially, they might swing independently, each following its own rhythm, but they are weakly coupled through the beam that supports them. Gradually, over many oscillations, they begin to influence each other. Eventually, they synchronize, swinging in perfect unison or in perfect opposition, locked into a relationship where each reinforces the other's motion. This is called entrainment or synchronization, and it happens throughout nature wherever oscillating systems are coupled, even weakly. Fireflies flashing in groups, their bioluminescent signals gradually synchronizing until entire trees pulse with coordinated light. Women living together, finding their menstrual cycles drifting into alignment. Circadian rhythms adjusting to the daily light-dark cycle, synchronizing our internal biological clocks to Earth's rotation. Could something similar happen between solar and terrestrial cycles? Could periods of high solar activity gradually entrain with periods of high seismic activity, each influencing the other through subtle couplings until they fall into synchrony? The mechanism would be indirect, operating through the cascades we have described: solar activity affecting geomagnetic storms, affecting crustal stress, affecting earthquake triggering. But indirect mechanisms can still produce real synchronization if the coupling is persistent and the systems are capable of adjustment. This is speculative, reaching beyond what current data can confirm or deny. But it is worth contemplating as you rest here, as your own rhythms slow and quiet, as your breathing deepens and your heartbeat softens. You are a system of cycles yourself, nested rhythms from the firing of individual neurons to the slow healing of tissues, from the rapid exchange of gases in your lungs to the gradual renewal of cells throughout your body. And you are coupled to external cycles, entraining to the day-night cycle, responding to seasonal changes in light and temperature, influenced by the lunar month in ways both subtle and profound. You are not separate from the universe's rhythms, but embedded within them, a note in a vast symphony that includes everything from quantum fluctuations to galactic rotations. 3I Atlas's passage through our solar system is a unique event, not a cycle, but a one-time visit. Yet it may have triggered or enhanced cycles that were already present, given them a nudge at a critical moment, added energy to oscillations that were already underway. Like a conductor, bringing in a new instrument at exactly the right moment in a symphony, the comet's influence might have been small in absolute terms, but significant in context, changing the texture of the performance even if it didn't change the underlying composition. The earthquakes that have multiplied during this period will eventually subside. The Sun's activity will moderate as 3I Atlas recedes and the current solar cycle progresses toward its next minimum. The frequency of geomagnetic storms will decrease, and Earth's crust will continue its slow conversation with itself, accumulating stress and releasing it in tremors that follow patterns too complex for us to predict precisely, but too regular to be entirely random. What remains after this episode will be data, measurements, records of what happened when an interstellar visitor passed through our neighborhood, and coincidentally or causally, the Sun grew more active and the Earth trembled more frequently. Scientists will analyze these records for years, debating interpretations, refining models, gradually building toward a deeper understanding of how our solar system works as an integrated whole rather than a collection of isolated objects. And perhaps, if we are fortunate, another interstellar comet will visit decades or centuries from now, providing another opportunity to observe and learn. Each visitor is precious, a gift from the cosmos, bringing information from stellar systems we can never visit, allowing us to test theories about how planetary systems interact with external perturbations. Let these thoughts drift through your awareness like leaves, floating on a stream. You don't need to hold them, don't need to remember them. They are simply part of the tapestry of understanding that we are weaving together, you and I, in this quiet space where words become dreams and knowledge becomes rest. Your breathing is so slow now, so gentle. Each inhale brings in peace. Each exhale releases whatever you no longer need. You are safe here, held by time's own rhythm, cradled in the vast cycles that govern stars and planets, and the slow dance of tectonic plates. Rest deeply in this knowledge, rest completely in this moment. The story continues, soft as shadows, gentle as moonlight on water. Rest in this recognition, let it dissolve any remaining tension, any fear, any sense of separateness or vulnerability. You are held by the universe itself because you are the universe itself. You are safe in the deepest possible sense, not safe from change or loss, but safe in being, in existing, in participating in this grand adventure of consciousness, experiencing itself through infinite temporary forms. The story is almost complete now. The comet has passed, the Sun has quieted, the Earth continues its ancient conversation with itself, and you, dear listener, have journeyed through it all, exploring connections that span from stellar fire to planetary trembling, from ice born around another star to fault zones deep beneath the surface you walk upon. What remains is simply to rest, to let the journey settle into your bones, to drift into sleep if sleep will come, or into deep relaxation if it won't. Either way, you are held. Either way, you are safe. Either way, you are home, because home is not a place but a recognition of belonging, and you belong to everything, and everything belongs to you. In the quiet after the storm, in the stillness that follows intensity, there is space to reflect on what we have learned, not with the analytical mind, but with a deeper knowing, a recognition that comes from having traced the threads of connection from one domain to another, from sky to stone, from fire to ice. The hidden connections we have explored tonight are not hidden because they are secret or deliberately concealed, but simply because they operate at scales and through mechanisms that our ordinary perception doesn't register. We see the sun rise and set. We feel earthquakes when they are strong enough. But we don't directly perceive the solar wind or the magnetosphere or the induced currents flowing through rock miles beneath our feet. These remain invisible, detectable only through instruments, understood only through theory and painstaking analysis. Yet they are real as the visible phenomena they connect. And recognizing their reality, acknowledging that what we see is only a small fraction of what exists, This opens us to a broader understanding of how the universe works. It teaches humility, the recognition that despite all our knowledge, we remain largely ignorant of the full complexity of existence. But it also teaches wonder, the delight of discovering unexpected connections, of finding that the universe is even more intricately beautiful than we previously imagined. The specific connection we have traced tonight, from interstellar comet to solar activity to geomagnetic storms to earthquake triggering, may or may not be as strong as it appears in the correlations. Future research may confirm it decisively, or may reveal that we have been seeing patterns in randomness, finding connections where only coincidence dwells. Science is always provisional, always subject to revision as new data arrives and better theories emerge. But regardless of whether this particular connection proves real, the possibility of such connections, the recognition that the universe operates as an integrated system rather than a collection of isolated phenomena, this understanding is solid and will not be overturned. Everything is connected, everything influences everything else. The only questions are how strongly and through what mechanisms. This principle applies not just to cosmological and geological phenomena, but to everything, including you and your life and your relationships with others and with the world. You are not an isolated consciousness trapped in a body that is itself isolated from everything else. You are a node in a vast network of relationships connected to other people through communication and empathy and the inevitable influence you have on each other's lives. You are connected to the biosphere through the food you eat, the water you drink, the air you breathe, participating in cycles of matter and energy that link you to plants and animals and microbes in an endless exchange. You are connected to the planet through gravity and through the physical presence of your body pressing against Earth's surface. You and the planet in constant conversation through forces so familiar we forget they exist. And you are connected to the cosmos through starlight and cosmic rays, through gravitational waves rippling through space-time from distant cataclysms, through the expansion of space itself carrying distant galaxies away, while simultaneously providing the dark energy that may eventually tear apart even atoms in the incomprehensibly distant future. Every level of reality, from quantum to cosmic, touches you, influences you, includes you as an integral part. Understanding this doesn't require believing anything on faith. It is simply a matter of following the chains of causation, of recognizing that no boundary is truly absolute, that everything that seems separate is actually in constant exchange with everything else. The skin seems to separate you from the environment, but molecules pass through it constantly. Your thoughts seem private, but they are influenced by language and culture and conversation, by ideas that have been passed from mind to mind for generations. Even time, which seems to separate past from present from future, is revealed by physics to be more fluid than common sense suggests. Past events reach into the present through causation and memory. Future events reach backward through quantum mechanics, where certain experiments seem to depend on measurements that haven't been made yet. And the present moment, examined closely, dissolves into a blur of ambiguity, a knife edge between what was and what will be that has no finite width. These are not mystical or supernatural ideas, but straightforward implications of our best scientific theories. The universe is strange, stranger than ordinary perception suggests, stranger perhaps than we can fully imagine, but it is knowable, at least partially, through careful observation and rigorous thought. And what we come to know again and again is connection, relationship, the utter impossibility of isolation. 3i Atlas reminded us of this by connecting stellar systems across light years, by possibly connecting solar behavior to terrestrial trembling through cascades of subtle influence. But every comet, every falling star, every photon of light carries the same message if we are willing to read it. You are not separate. You are not alone. You are part of everything, and everything is part of you. Rest in this understanding. Let it become not just an idea, but a felt sense, a recognition that settles into your body as surely as gravity does, as surely as breath does. You are held by connections that cannot break, because they are not external bonds, but the very substance of what you are. You are relationship, process, pattern, not thing but action, not noun but verb, not isolated entity but nexus of influences. And from this recognition flows peace deeper than any temporary circumstance can disturb. Not because circumstances don't matter, they do, they absolutely do, but because beneath and beyond circumstances, there is this fundamental belonging, this unbreakable connection to the totality of existence. You are home, always have been, always will be, because home is not a location but a recognition of what you are, which is everything, which is the universe knowing itself through this particular temporary form. Sleep now, if you will, or rest in quiet waking, held by hidden connections that span from your heartbeat to the trembling earth to the distant stars. All one movement, all one breath, all one vast presence appearing as many, playing all the roles, dreaming all the dreams, including yours. What does it mean to truly wonder about something? Not just to be curious, not just to want an answer, but to let a question open you up, to let mystery become a doorway into a deeper relationship with existence itself. This is what the story of Three-Eye Atlas and the Earth's trembling has offered us tonight. Not primarily answers, though we have explored some possible answers, but wonder, the gift of recognizing how much we don't know and how beautiful that unknowing can be. Children have this gift naturally. They look at the world with fresh eyes, seeing not just objects and facts, but possibilities, mysteries, invitations to imagination. Why is the sky blue? Where do stars come from? What makes the ground shake? These questions bubble up spontaneously because children haven't yet learned to take the world for granted, haven't yet covered over the fundamental strangeness of existence with a veneer of familiarity and assumed understanding. As we grow older, we often lose this capacity for wonder. We learn the standard answers to standard questions and stop asking new ones. The world becomes ordinary, predictable, explained. But this is an illusion, a comfortable fiction we tell ourselves to make navigating daily life easier. The world has not become less mysterious. We have simply stopped paying attention to its mysteries. Science, at its best, is a way of recovering that childlike wonder while adding the discipline and rigor of careful observation and logical thought. It asks, what if we really tried to understand how things work? What if we didn't accept easy answers, but kept pushing deeper, kept asking follow-up questions, kept insisting on evidence and clarity? And what science discovers again and again is that the universe is far stranger and more wonderful than common sense suggests. The story we have traced tonight exemplifies this. Common sense says that comets are just icy rocks, that the sun is just a ball of fire, that earthquakes are just geological events, and that these things are separate, unrelated, occurring for their own independent reasons. But when we look more carefully, when we trace the connections, we find that the boundaries between these phenomena are porous, that influences flow from one to another in ways that challenge our assumptions about what is separate and what is connected. A comet from another star might influence our sun's behavior. Solar activity might influence Earth's magnetic field. Magnetic disturbances might influence tectonic activity. Each connection is subtle, each causation uncertain, but the possibility exists, and exploring that possibility opens up new ways of seeing how our corner of the universe operates as an integrated system. And this specific example points toward a more general truth. Everything we think of as separate is actually interrelated. The boundaries we draw between earth and sky, between living and non-living, between mind and matter, between self and other, these boundaries are useful for practical purposes, but they are not fundamental features of reality. They are constructs, conventions, ways of carving up the seamless flow of existence into manageable chunks that our limited minds can grasp. When we relax our grip on these boundaries, when we allow ourselves to see the connections that run through and beneath and beyond them, the world becomes enchanted again, not in the sense of being magical or supernatural, but in the sense of being full of hidden relationships, secret sympathies, unexpected influences. It becomes a world where anything might affect anything else, where tracing causes becomes an adventure that can lead anywhere, where understanding one thing opens doors to understanding everything. This is the gift that wonder brings. It transforms the world from a collection of facts to be memorized into a living mystery to be explored. And the exploration is endless because the mystery is inexhaustible. We will never reach a point where we know everything, where every question has been answered and every connection traced. There will always be deeper levels, subtler influences, new phenomena to discover and understand. And this is not a bug, but a feature. It means that wonder is not just for children or for one particular phase of life, but a possibility that remains open always, regardless of age or knowledge or circumstance. You can know a great deal about astronomy, geology, and solar physics, and still wonder at the connection between a comet and an earthquake. You can understand the mechanism in principle and still feel amazed that such distant phenomena can touch each other. In fact, understanding often deepens wonder rather than dispelling it. When you know how intricate the mechanism is, how many intermediate steps are involved, how precisely everything must align for the connection to manifest, the fact that it happens at all becomes even more remarkable. Wonder is not the same as ignorance. Wonder is what happens when understanding reveals greater depth, when answering one question opens up 10 new ones, when you realize that what you thought was simple is actually breathtakingly complex. As you rest here now in the deep quiet of night or the soft light of early morning, let yourself wonder, not about anything in particular necessarily, but as a general orientation toward existence. Let yourself not know. Let yourself be okay with uncertainty, with ambiguity, with the recognition that mystery is not a problem to be solved, but the very nature of reality itself. The universe is not a puzzle that has a final solution. It is an inexhaustible wellspring of pattern and possibility, creating itself anew in every moment, always exceeding our comprehension, even as we gradually extend the boundaries of what we understand. And you are part of this creative process, not just observing it, but participating in it, because your consciousness, your awareness, your wondering itself is part of how the universe comes to know itself. When you wonder about the connection between a comet and an earthquake, the universe is wondering about itself through you. When you feel awe at the vastness of space or the intricacy of tectonic processes, the universe is feeling awe at itself through your awareness. You are not separate from what you observe. You are the universe observing itself, thinking about itself, marveling at its own complexity. And this recognition, this collapse of the boundary between observer and observed, this is perhaps the deepest teaching that wonder offers, that there is finally no separation, no inside and outside, no you and world, but only this, one vast presence, appearing as many, experiencing itself through infinite temporary forms, each form a unique perspective on the whole, each perspective equally valid, equally precious. Rest in wonder now, not in any particular thought about anything, but in the open awareness that allows wonder to arise, the spaciousness that doesn't need to grasp or comprehend or fix, but simply allows everything to be as it is, mysterious and beautiful, and forever unfolding into new forms. And this is peace. This is home. This is the gift that 3i Atlas brought from beyond the stars. Not just scientific data, not just a potential mechanism for earthquake triggering, but a reminder to wonder, to remain open, to never stop marveling at the extraordinary universe we are privileged to briefly inhabit and ultimately to be.